In this video, we'll be looking at problems from 5.1. Recall in Google Classroom under classwork, where most of the materials are, there are the textbook solutions, and I've recently posted chapters 5 and 6 in here. And these solutions are the teacher's edition. They are really extensive. It shows not just the answer, but how to work out the problems in a step-by-step fashion for some of them. So if you get hung up, this is definitely a resource that might be helpful. Keep in mind that the assignment sheet's on in our spreadsheet for 5.1. They're mostly the 75% problems. They're not many, and beyond that, we have 1 through 5 all. 7 through 21 odd. If it's a range, it's just odd. 22 through 25 all, unless it obviously says all. 27 through 39 odd. 41 through 49. 50 through 57 all. Through 49, I should have said odd. If it shows a range, it means just odd. All right, let's look at a few of those problems. 6 through 21 says, draw an angle in standard position with the given measure. Standard position means the initial side will be on the x-axis. So if you have given an x and y axis, standard position means the vertex is at the origin. We have an initial side on the x-axis, and the terminal side is at that particular degree. So in this case, 30 degrees would be like right here. That is a 30-degree angle in standard position. Negative 80 degrees means it would be moving downward 80 degrees. So negative 80 degrees would be right here. This is negative 80 degrees, which is the same as 280 degrees in this direction. It is the same terminal side. We call them coterminal, two angles that have the same terminal side. Notice that 280 and 80 sum to 360. All the way around is 360. All the way around our circle is 360 degrees. A big concept in this section is this idea of radians. Radians are just another way to measure angles. We discussed this in geometry. 360 degrees all the way around the circle is the same as 2 pi radians. And you can write the word radians, but if you don't write the word radians, if you just write pi, that's the radians part is implied. So naturally, 180 degrees would be pi radians. 90 degrees would be pi halves. Half of that, 45 degrees, would be pi fourths. I'm just cutting pi halves in half. To make the conversion, just consider this statement is really handy. 180 degrees is pi radians. All right, so if you're converting from radians to degrees, it is super simple. Simply substitute 180 into the degrees position. So if I wanted to change pi third radians into degrees, where the pi is, pi thirds radians, I'm simply going to substitute 180 degrees. So this is equal to 180 degrees over 3. Which is 60 degrees. All right. In place of pi, I substituted 180 because 180 degrees is pi radians. If I'm going the other way, if I'm going from radians, from degrees to radians, let's say I have 100 degrees here, number 34. 100 degrees, and I want to know how many radians. Just keep in mind that same conversion factor. 180 degrees is pi radians, and you'll do a little dimensional analysis like you did in chemistry. Just make a conversion factor where 180 degrees in pi are a fraction. You can write radians here if you want. So pi radians is 180 degrees. This is just 1. It's a special version of 1. So now when I'm multiplying together here, the degrees cancels the degrees. And so I'm left with 100 pi over 80 over 180. 100 pi over 180. The 0 would cancel with the 0. 10 and 18, 2 go into both of those. 2 goes into 10 5 times. 2 goes into 18 9 times. So we'd say it's 5 pi ninths radians. You don't, again, if you don't write the radians, it's implied to be radians, but you could write the word radians. You can do this multiplier in either direction, but doing it here, you're going to end up with exactly what I said. So I'm going to do this pi 3 conversion using this conversion factor just flipped over. So if I have pi over 3 and I multiply this by the same conversion factor, but I'm flipping it over the other way, 180 over pi, because this is degrees, I want to cancel the pi with the pi. When that happens, you see that all that's transpired is 180 went in place of pi. So keep the fact in mind that a whole trip around the circle is 360 degrees, a whole trip around the circle 2 pi. That makes sense. You know, we do say circumference is equal to 2 pi times the radius. In fact, that's where this comes from. This radian thing, it is the angle such that the radius if you created an angle such that this arc length here, the arc length, is the same as this radius, this angle is 1 radian. That's what we mean. It's the angle that is cut whenever the arc length is equal to the radius. It's about a little bit less than 60 degrees. And you could, if you take 360 degrees and divide by 2 pi, that's a little bit more than 6. This is like 57, 58 degrees. That's what 1 radian is. All right. So that helps with 6 through 21 and with 28 through 39, really. Let's look at 22 through 25. In terms of the pre-calculus end of it, the 22 through 25, how it's going to impact you moving forward, not huge, but just in terms of the general mathematics, 22 through 25 is, I would say, it's the most important problems in 5.1 in terms of your general math knowledge. This is a operation that you've done before and should just make total sense. First, recall circumference of a circle. Circumference is equal to 2 pi r. The circumference being all the way around the circle. Area of a circle, pi r squared. Two of the most basic formulas. You've been looking at them for several years now. Notice the similarities. Both have pi, both have radius, both have a 2. Circumference is times 2. The area is squared. That makes sense. Area is squared. Well, the sector, the area of a sector, and the circumference and the arc length are using the same formulas with just a little proportionality multiplier. And we saw this last year in geometry. Area of a sector. Area of a sector. And a sector is if the circle were a piece of pizza, the sector is the actual piece of pizza itself, that area. Area of a sector is this same pi r squared. But then we're going to have a multiplier, a part over whole multiplier here. Over a whole times pi r squared. Well, what's my whole? Well, it depends on what the measure is in. It's either 360 degrees or it's 2 pi, depending on if we're in degrees or radians. The part is the angle we're talking about. The angle in question. Okay. I'm going to do one like number 22. Okay, this is like 22. Let's say my angle, let's draw another circle. And let's say the angle was 80 degrees. Okay. So if I want to find the area of the sector, I'm making a proportion that is part over the whole. The part of the circle we're dealing with is 80 degrees. The entire circle is 360 degrees. And then it's just pi r squared. So we need some radius. Let's say our radius is 5. Hopefully you remember this from geometry. 80 over 360, that would cancel. 8 over 36 is whatever it is. 4 goes into both of those. 2/9. 2/9 is 0.22 repeating times pi and 5 squared. 5 squared is 25 times 2 would be 50. We would say this is 50 over 9 pi whatever inches units squared. And this is not the pi's in radians. This is the number 3.14. If we wanted an approximate answer, we'd multiply that out. So 50 over 9 is about a little bit, it's about 5.5, 6, and that's about 3 point something. So those two multiplied together are like about 19. All right, it's about 19 units squared. That would be the area of that thing in there. All right, and so the other important formula is arc length. Arc length is typically we use S for arc length. Now, the formula I'm giving you here is a little different than the one that the book is giving you. The book's giving you one that's specifically in radians. And if you look at the conversion, you'll see that it's exactly the same. I really want you to, I mean, this is the understanding of the thing. So do use, think about them in terms of what I have here. Arc length given by S is, again, part over whole. The part of the circle we're dealing with divided by the whole circle, times our circumference, which is 2 pi r. Keep in mind the arc length, again, with the pizza analogy. If we had a pizza, the arc length would be the length of the crust, just that length out there. It's not an area, it's a length. That is what I mean by arc length right there. All right, so I'm looking at one like number 24. Like number 24. I'm just going to change these numbers here. Let's say this one was pi sevenths. It's way bigger than that, but let's go with it. Let's say this was 6. All right. Again, arc length. We're going to do part over the whole. In this case, the part is our angle. It's a pi sevenths angle over whole. The whole circle is 2 pi radians times 2 pi r times 2 pi. Our radius in this case is 6. All right. Well, this is a 2 divided. This is a 2 multiplied. They would cancel. This is a pi multiplied. This is a pi divided. That I'm going to show the invert and multiply here so you can see clearly what's happening. I'm going to put this over 1. When you have a fraction divided by fraction, we're going to have to be doing quite a bit of this, so pay close attention. What we're saying here is it's pi sevenths divided by pi over 1. Keep, change, flip, multiply by the reciprocal. This becomes pi sevenths times 1 over pi. The pi cancels with the pi to leave 1/7. Think this makes sense. This is a pi multiplied. This is a pi divided. They're gone, leaving a 1 here. Essentially, you have 1/7 divided by 1. It makes sense that it's 1/7. That's all 1/7. We have a pi and a 6th left. So our total 6 times 1 times pi would be a 6 pi in the numerator and a 7 in the denominator. That would be our exact length. And the approximate length, we would just, we could multiply by pi. So that's like 18 divided by 7, be 2 point something. a little bit less than 3. Let's call it about 2.7. Again, this time it's just units, it's not units squared. That concludes this video.